Hello, in this video we're going to define a search function, and we're going to do this recursively. And this is a beautiful definition presented in a textbook by David Hunter called Essentials of Discrete Mathematics. And my point of putting it in this video is to highlight kind of how that works and provide some additional examples to build on what David Hunter has presented in his book. So we begin with a definition. We'll define the search of T comma L, where T is a target. T is what we're looking for. And L is an S list. It's a sorted list. And we're going to define this search function by the following base case. So if L is equal to X, in other words, if our sorted list just has one element in it, namely X, this is an S list of depth 0. And then our search is going to equal true or false as following. So it's going to be true if T, our target, is equal to the only item in our list. And it's going to be false if T is not equal to X, right? So if you have just one thing in the list and you're looking for it, it's either true or false depending whether your target's equal to that element X. And then our recursive case, we'll define this as R. In this case, let's suppose we've got a list that's depth greater than 0. So if L equals two S lists put together, X and Y, and so we'll denote this, L is an S list of depth P greater than 0, and X and Y are S lists. Okay, so if that's our setup, then search of T comma L is going to be either true or false. And that's going to be defined as this recursive step, whether the search of T in X or the search of T and Y is true or false. And so that's our OR, that's our disjunction right here. This is the classic OR statement right there. So I'd like to look at an example of how this would work. Okay, so let's look at an example. Let's let our S list, here's our S list, it's given by the following. We've got a 1, 4, and 6, 8. Okay, and our target is going to be 6. So let's begin. We want to compute the search of our target, which is, I'm going to put square brackets to help with the notation here. Our target is 6, and our list that we're searching on is capital L. All right, and according to the rule here, if L consists of X and Y, then we just break it apart. So we're going to break this apart as the search for target 6 in our first little list here, which is going to be 1, 4. So we'll do that. Disjunction, there's our OR statement. Search, we want to see if our target 6 is in the other list, which is Y. So I'll put that here, that's 6, 8. And I'll stick with the color conventions. Okay, so this breaks down to saying, hey, we want to look for the 6 in the first. Right, again, we've got an X and a Y sitting in here, so we're going to break it apart again. We're going to go 6 and 1, or search 6, 4, or now we're over here breaking apart these two elements into two different lists, X and Y. So we've got the search function. We're looking for 6 6, or searching for the 6 in a one-element list consisting of 8. All right, so let's work through this. Search 6, 1. Now we're down to the base case of the definition of search, right? It's now just a direct comparison. Is 6 equal to 1? And the answer is no, so the answer for this first piece is going to be false. Similarly here, 6 is not equal to 4, so we've got another false. 6 is equal to 6, so that's going to be a true. And the last evaluation, 6 is not equal to 8, so that's a false. But anytime we've got one true component to a disjunction, the whole statement is going to be true, so this turns out to be true. So we search this list using the search algorithm. Now, this wasn't a very clever algorithm. We literally marched through each element in the list, and this was a lot of checking. A quicker way of proceeding is something called a B search. You might kind of think of this as a binary search. So I'm going to define a new search. And this is also a definition presented by Hunter. This is called a B search. So B search of T and L, and again I'm going to say T is a target and L is an S list. So B search of TL is defined as follows. So we've got a base case, I'll label that B. The base case, if our list just consists of one element, namely X, this is a list of depth 0, then B search of T comma L, it's either going to be true or false. So it's going to be true if T equals X, and it's going to be false otherwise. And that's pretty much the same as before, so I'm going to kind of scoot over that more quickly. But now what's different here is this recursive case. So let's suppose L consists of two S lists. So L has depth P, which is greater than 0. And let R be the last number in X. Okay, so here we go. B search of TL is going to be B search of TY. So we're going to get sent over to the second S list, and then we're going to get sent there if T, our target, was bigger than R, the last element in X. And we'll do an example to show this. B search of T comma L is going to be B search of T comma X. Right? We're going to get sent to the first of those S lists if T is not greater than R. Okay, let's do an example to kind of work through this. So here's our example. The example I want to look at, let's let our list be the following. So we'll say we've got 1, 2, and 6, 8. Okay, and let's say our target is 8. All right, here we go. B search, and we're looking for the target 8, and we're searching in list L. So we're going to go B search of 8 comma L. This breaks down to looking at B search of what? Well, let's see. We've got two lists in here. We've got X and we've got Y. Okay, we got two lists in here. Now this R, let me get a different color for us here. This R was the last number in X. So let's see, here's the last number in X. And the rule for B search says, hey, if T, remember T is 8, if T is greater than R, so if 8 is greater than R, which is 2, that's true, right? Check. If T is greater than R, then we're going to be sent to searching in that second list, right? So let's put that in here. So we're going to do B search, still our target is 8, but now we're searching in list Y. And let me write down what that list looks like. So this is B search of 8, comma, here's our YS list. It consists of 6, comma 8. Okay, so now, again, we've got two little pieces in here. We've got an X and we've got a Y. And the last number in X, in this case, is going to be 6. Right? And again, if T is greater than R, well, T is our search item, that's 8, and that certainly is greater than 6, check. We're going to get sent to the second list, namely Y. So in this case, we've got B search of 8, and we're looking in list 8, and since 8 equals 8, this is going to be true.